Hello friends, as we are aware that measurement of a physical quantity involves choice of the standard unit and the comparison of the object to be measured with the standard. For example, if we want to measure the length of a table, we can use, if we are taking the handspan as the standard, then we can compare the length of the table by our handspan. But today we are going to discuss the measurement of large distance. Here a question arises, why do we need different methods to measure different sized quantity? For example, the length of the table can be compared with the meter scale. It can be compared with our handspan. So we can say easily the length of table can be measured. Such a method is called the direct method. But if we want to measure the distance of moon from the earth, it is not possible to compare this distance with our handspan or the meter scale. So we must use some indirect method that we will see in this. Actually, the method used for measurement depends on the size of a physical quantity and the accuracy required. Once again, here what is accuracy? Suppose we want to measure the length of the table up to 1 millimeter. We can use the ordinary meter scale. But if we want to measure the table up to 1/10 or 1/100th of a millimeter, then meter scale will not serve our purpose. So, the suitable technique for measuring any physical quantity depends upon the magnitude of the physical quantity to be measured and the accuracy required in its measurement. So we can say two methods mainly involved. One is the direct method, other is indirect method. Let us see how some of the direct method and indirect method can be used for the measurement of large distances. First, parallax method. Here we must know what is parallax. Let us how here a point P is far away. We want and we are here. We want to measure this one. Let our first we see the P, the point from our left eyes. And again we see the same point from our right eyes, one by one. Then we will find certain here angular difference. This angle is parallactic angle or parallax. This is parallax. If the distance between our left and right eyes is b, this distance is called basis. This distance is basis. Basis. If the distance here, let these two distance here be d, then and assume this b as a circular arc, then theta equal to this LR by d. So we can say this theta equal to, what is LR? It is b. It is, this distance is b, and by d. Now here, what is the purpose of taking this angle as a circular arc? What is the purpose here? Let us here a circle of radius r. Here, this arc length is L. This arc length subtend angle theta at center of the circle. Whole arc, then circumference, subtend angle 360 degree, here 2 pi. Then theta equal to L by R. L by R. Now it should be the clear one. Why in the previous one this basis considered as, here it was L, it is R, this point as P, then this B is taken as the circular arc. If here arc length is equal to the radius of the circle, that's L equal to R, then we can say theta equal to 1, that is 1 radian. So if L equal to R, then theta equal to 1 radian. 1 radian. That is also the rad in short form. So here, and that is whole circumference subtend angle 360 degree, that is 2 pi radian at the center. So we can say pi radian equal to 180 degree, and or 1 degree equal to pi by, or here 1 degree equal to pi by 180 radian. So let us see here what are the different methods. First, in the parallax, the same one. Here, consider a point P, that is a planet, at very far away from our position. Then, as cited earlier here, this L, left eyes, right eyes, this angle theta, as cited just right now, parallax angle or parallactic angle, and this is LR is B. As this distance is very far away, so if we just compare B by D, it's a ratio of this, and this is, that will be less than 1. So the value of theta is very small. For that purpose, the circular arc is used, that is theta equal to B by D. Remember here theta is in radian. Now how we can measure measurement of the size of angular diameter of an astronomical object. Let it be. Here it is the Earth. It is an astronomical object we want to measure. For this purpose, we select any point on the Earth and see the diameter. Then we can say here angle. This angle is called parallax angle. So here basis will be d and this distance is d. So again by using the same one, that is theta equal to L by R. So here alpha equal to the basis, which is the d, and this distance. So the diameter will be alpha into d. Another method is reflection method or echo method. There are some cases in which reflection method is very much helpful. For example, distance of a hill, distance of moon, radio detection and ranging, that is the radar, sound navigation and ranging, that is sonar. Let us see one by one. First here, distance of a hill. Let from this point a gun is fired and its so sound will travel, and after striking the hill, sound will reflected back, so echo will be received. So this time can be measured, and if time is measured and we are knowing the speed of sound in air, let that is v, and the distance of a hill from the observer is s, then what we can say, v into t equal to 2s, or s equal to v into t by 2. So this formula we can use. Next is distance of moon. Just we have seen to find the distance of a hill from an observer, sound wave is used. But moon is very far away, so in place of sound wave, laser beam are used. Laser is a monochromatic, intense and unidirectional. If time is taken for the laser beam in going and returning from the moon is t, then what will be the total distance traveled by, that is now the laser, which is a light. The total distance traveled by light is 2s. S is the distance between observer and the moon. So that 2s equal to c into t. So s equal to c into t by 2, where c is the speed of light we are knowing, and that's value is 3 into 10 to the power 8 meter per second. Again, distance of aeroplane. Radar station transmits radio waves, and that radio waves propagates with the speed of light, and again reflected wave is received by the receiver at the radar station. So by same process as here, distance is calculated. Now distance of submarine in the sea. For this purpose, in place of laser or in place of radar, an ultrasonic wave is generated and sent, and the reflected ultrasonic waves are received, and by same here s equal to v into t by 2. Now few questions here. Practice this, answers given and verify. Thank you.